Okay, guys, so we're still in the midst of learning about these properties of logarithms. Yesterday we condensed expressions with the product power property, quotient property, power property. Today we're going to be expanding expressions with those same properties. So I know I wrote these notes yesterday. I'm going to rewrite them a shorter version today. So the product property, if you start out, now I'm kind of writing them backwards as compared to the word yesterday, because yesterday we were condensing and today we're expanding, which is sort of the backwards or the opposite of that. So if you have log of a times b, you can expand this out into log a plus log b. So if you start with one log, it expands into two logs. The times expands into plus. And hopefully that makes sense. You know that adding and multiplying are related to one another. Similarly, for the quotient property, log a divided by b, you can split this into two logs, log a and then minus log b. And it's easy to know, just like adding and multiply go together, subtracting and division go together. In fact, the symbol for both is the same. It's a horizontal line, so it doesn't get more obvious than that. The power property, if you start with a log of an argument which has a power, then to expand that, you bring the power out in front. And I know that looks like blog. That's kind of dumb. But anyway, you bring this power down in front of the L. So it's b times log a, and then that is considered expanded. So we're going to look at some examples of how you can use these properties to expand the various logarithm problems. So these are going to start out fairly simple, like one step and you're done, and then we'll get into ones that take 2 or 3 or 4 steps to do the whole thing. And that's what we're looking at. So this first one is basically just a repeat of the notes that I wrote up here, log a times b. The parentheses don't change anything. They're totally fine there. So log a times b just turns into log a plus log b. The times splits into two logs and then it's plus in between. Number 4, log base 2 of x to the 5th power. So this one, we're going to use the power property. You know what I'm going to do? Here, this was the product. I did this yesterday. I'll do it today too. I'll just make little notes of what I'm doing here. So this one, since we have an exponent or a power, we're going to do the power property. So that means that this 5 comes down in front of the logarithm. It gets multiplied. So 5 times log base 2 of x. And then, of course, there's no 5 there anymore. And that's it. That is considered expanded. So here's this one. Here's this one. Number 6 is division. So we're using the quotient property. So it's log of the top minus log of the bottom. And that's it. That is fully expanded. That's all there is to it. Okay, so let me get those into mind. I'm going to go check 2, 4, and 6 on the answer key real quick. So 2, that's right. 4, yep, put the 5 in front. 6, log u minus log v. Good. So we got those right. Remember, these properties work for any logarithm. So I did a base 2, and then this one was a base 10. That one was a base 10. Number 8 is a natural log. Now, here we have something sort of interesting going on. The first thing we're going to do is focus on that division bar right there. So I'm going to do the quotient property, ln of x minus ln of y to the 4th. So that was a quotient property. But now I can go one step further. How do I want to do this so it makes sense? You know what? Hold on. I'm going to work sort of vertically instead. So first I did a quotient property. I'll put the equal sign up here. So, okay. Then this second logarithm, ln, has a 4, a power. So I can now do a power property, and I can bring that 4 down in front of this ln, so it's 4 times ln of y, and then that should be it. We've done everything we can possibly do to expand it. We've taken care of the quotient, we've taken care of the power. Quotient, power. So let's look at the answer to number 8. And there it is. Number 10. Okay, so this one also has a quotient and it has a power. But if you compare it to number 8, there is a distinct difference. Let me erase that so it's a little clear. You see on number 8, this power only applied to one of the variables. Here it applies to both of the variables because of those parentheses. So that's going to change up the order in which we do things a little bit. I need to do the power property first and put this 2 in front of here. So that's going to give me 2 log base 8 of u over v. Now I can focus on the division bar, the fraction bar, whatever. I can do the quotient property. Remember, a quotient property splits it into 2 logs, with a minus sign in between. But now that there's the 2 in front of the logarithm, it's sort of locked in there. So I need to write 2 log base 8 of u and then 2 log base 8 of v. So the division bar splits it into 2 logarithms with a minus sign in between. That 2 sort of goes along with both of them. And it kind of makes sense because the 2 was applied to both of them in the original problem. So that answer is a little different than this one. This one, the 4 only went here because the 4 was only stuck on the y. This 2 was stuck on the u and the v, so it's in front of both of them in the final answer. Or at least it should be. Let me go down and check. By the way, why do I always check my answers when I'm teaching like this? I have this nightmare that I'm going to teach a whole lesson and make a bunch of mistakes and not check any of them or not catch any of them as I go, and then you'll watch a video and learn completely wrong how to do something. It's not like I have a classroom full of you guys in front of me who can yell at me when I make a mistake and I can go back and fix it, erase the board or whatever. So yeah, I'm going to be checking my answers unless I forget, because yeah, I forget stuff. Okay, so number 12. What do we have here? We have multiply and we have a power. The power does not apply to the whole thing, so I'm not going to deal with that first. I'm going to deal with the multiply first. So I'm going to use the product property to get log base 9 of x plus log base 9 of y cubed. So I split this times into plus. Now I can use the power property, not on the first logarithm. The first logarithm doesn't have a power, so I can't really simplify, or I can't expand that at all. Log base 9 of y to the third, here I can take that 3 and make it a coefficient or multiply it by the logarithm. And now this, wow, that was weird. This is fully expanded. Number 12, let's check. And there it is. I don't know if any of you are actually pausing this and writing notes or how this is going over. Maybe you can shoot me an email or leave a private comment or public comment or something. You know, I don't watch the videos, I just wing it, or I watch every video and take all the notes or whatever. Okay, number 14. This one we're going to expand. Now it has multiply twice. It does not have any powers at all. So this is just going to be one step. We're going to use the product property, but we're going to sort of use it twice at the same time. So it's going to be log base 2 of x plus log base 2 of y plus log base 2 of z. Think of it as both of those times signs turn into plus signs, and the logarithm splits into 3 logarithms, 1x, 1y, 1z. And there's nothing else to expand. So let me see. Yep, same exact answer. And look at 16. So we got some fractions going on here. Let's see what's up with that. Okay, so we've got a power times. Technically there's another times there even though they didn't put the dot. And we also have a square root. So here's what I'm going to do. I am not going to use a law or property of logarithms yet. I am just going to rewrite the problem, because as we've studied a few times now, a square root is the same thing as a 1/2 power. Just like a cube root is a 1/3 power, a fourth root is a 1/4 power. So square root of xy is going to be x to the 1/2, y to the 1/2. They both get half powers since they're both underneath that square root bar. Now from here I can start using the properties. First, now they don't all have the same power, so I'm not going to do the power, or how do I want to say that? Yeah, they don't all have the same power, so I can't do the power property first, but I can split up the time sign. So I'm going to do the product property first. So it's going to be log base 3 of z to the 5th plus log base 3 of x to the half plus log base 3 of y to the half. Okay, so yeah, each time sign became a plus sign, just like in the previous problem. But now we've got these three powers, exponents, whatever you want to call them. But I'll call them powers since we're going to use the power property. So I can bring the 5 down and get 5 log base 3 of z plus, and then bring the half down, 1/2 log base 3 of x. Bring this one down, 1/2 log base 3 of y. Now, as far as I'm concerned, and many would be concerned, that is it. That is the answer, and it is right. The software that I use, that I've been using forever to make these papers, treats this slightly differently. You saw it yesterday. Multiplying by a half is the same thing as dividing by 2. So they prefer to write the answer like this, and then that one like that. Multiplying by a half is the same as dividing by 2. So the answer key should look like that, and it does. All right, the even problems are very similar to the odd problems. You look at 15 and look at 16, there's only really one substantial difference, that's a cube root instead of a square root, but the mechanics of how you work it out should be really similar. These two problems aren't necessarily the same, these two aren't necessarily the same, but this one's a lot like that one. This one is not like that one because we got the power here as opposed to the power there. So you can't really compare those two together. They don't really go like that. But to be honest, this one is a lot like that one. This one is actually kind of like that one. Even though this is divide and this is times, we have the idea of the power on the outside, the power on the outside. So as you do these, if you're getting stuck or having trouble and you're trying to look at the notes for similar problems, things that'll help, it's more or less there. Look, these two are pretty much the same. This one's a lot like that one. Oh, yeah, this one's a lot like that one. This one is a lot like that one. So, yeah, take it for what it's worth. Use the notes to help you for sure. If you have trouble or questions, obviously post a comment or email me and I'll help you in any way that I can. So good luck with this. Have a great day, and